Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. How are you all students? I hope you all are fine. And as you all know that we have completed chapter number 1 in the previous class, and we have to start lecture number 9, but it will be lecture number 1 of chapter number 2. So before proceeding, we should avoid or we should have some patience if we are angry, since this is the quote of Rasul Sallallahu Alaihi Wasallam that ला तग़ज़ब, गुस्सा मत किया करो, that we should recite औज़ु बिल्लाहि मिनश शैतानिर रजीम, or we should keep silent, or we should do ablution, means wuzu, or if we are standing then we should sit down, or if we are sitting then we should lay down. Okay, starting with, do you know that the main part of your brain that does the work of processing memories is called the hippocampus? You can see in the figure the part that is known as the hippocampus, and our brain has short-term memory as well as long-term memory. The front part of the brain is called the prefrontal cortex and is responsible for creating lies. You know, many people who talk to us, maybe they lie, or sometimes they lie. But what about why I'm discussing this? Because we are going to start our new chapter, and it is all about memories. So I'm discussing this with you. Okay, so pathological liars have more prefrontal white matter. Basically, those who lie and they do not consider us as the most feasible person, so they lie. They do not want to share anything with us. Basically, pathological liars who are habitual of telling lies. Okay, so they have the white matter in this part. You can see the prefrontal cortex. Okay, so what is the connection between it? That Allah subhanahu wa ta'ala is going to punish liars on the day of judgment, as in the Quran, Holy Quran, he says, no, if he does not desist, we will surely drag him by the forelock, a lying, sinning forelock. Allah Ta'ala is going to drag him by his forelock because the liars have white matter in the prefrontal cortex. Okay. Then here starts with the chapter number 2, that is the computer components. Component means part of a computer, and it may include hardware, software, or peripheral devices, means your input and output devices. And computer components means that we are going to discuss parts of computers. Then here we have 4 portions of this chapter, that is central processing unit, memory, storage, input output devices, and ports. So today we are going to start the central processing unit. Okay, let us start. Can you see the figure? That here we can see the 3 buses, that is control bus, address bus, data bus, all are included as a system bus. Why we are calling it as a bus? What is the purpose of bus in our real lives? Basically, bus is used to use for transport purpose, right? That one can travel either in the city, or they can travel from one city to another city. In the same way, there are buses and computers which help the data to travel between memory and input and output devices and within the CPU. Okay, so buses are used to transmit data information from one place to another place inside the computer, same to which we have discussed now. And what is memory? Memory is a place to keep data for later use. Computer memory can be classified into 2 categories, primary and secondary memory. We will discuss all of them one by one in the upcoming lecture. Okay, What are ports? Ports are the places at the back of the computer used to connect various external devices to the computer. What are ports? We will discuss in detail, but right now we can assume, we can say, how many of you have seen that we connect the VGA cable, means that blue connector, that black wire, which is having blue connector at the ends. So we connect those connectors with their devices. So these are ports. This is a real life example that in Gawada Port connects Pakistan and China for trade. Maybe some of you have heard about Gawada Port. So Gawada Port is used to connect Pakistan and China for trade. Moving on. What is CPU or Central Processing Unit? I hope you all have heard about it. Central Processing Unit is the brain or the nerve center of the computer system, we all know. And the processing or calculating functions takes place in the Central Processing Unit. Okay, now how does it calculate, or how it is going to process? Basically, raw data is provided, means any unprocessed data is provided, so it is transformed into meaningful information. Here is the difference between data and information. The data is unprocessed, means I'm giving you the example. Okay, if you are having raw egg, so if you want to fry, you can make it as a half fry egg, you can have it as a boiled egg, so it will be some meaningful ingredient of your breakfast. So in the same way, the raw data is provided, which is unprocessed, to the computer, and it transforms into meaningful information. Okay, it is a hub of processing activities. Basically, it is the main part where all the processing is done. So it is also known as hub of processing activities, because all the activities are performed or are processed in CPU. Okay, now this is the motherboard. What is a motherboard? I hope you all know, but if you do not know, we will discuss. Um, Basically, what is a motherboard? Motherboard is the basic type of memory, and there are a lot of chips located on the motherboard. As you can see, it is a rectangular card, which you can see in the figure. It is a rectangular card which is containing the circuits, and that connects the processor to the other hardware. And in many personal computers, many internal devices, such as sound cards and other devices, are housed on this board. Okay, what we need to understand here is that chip. Can you see the Intel chips? Yes, of course you can. So what is that chip? In large machine, CPUs require one or more printed circuit boards. On personal computer, the CPU is housed in a single chip called a microprocessor. What is microprocessor? Basically, it is an integrated circuit, that is a circuit that contains all the functions of a CPU. Without this chip, CPU is nothing. Okay, now we are going to discuss the block diagram of computer system with subunits of CPU. Okay, we are going to discuss each and every part in detail, and you can see in the figure that it is showing you the motherboard, and on motherboard we have three components. As you can see, uh, inside the CPU we have control unit and arithmetic logical unit, and after that primary memory is present. And apart from them, there are input and output boxes, and above all, they have storage unit. Okay, so now motherboard comprises of control unit, arithmetic logic unit, and outside it has primary memory. Now we will discuss what is control unit. Control unit, it takes instructions from the memory and processes the data. We will discuss what is RAM, but just listen that what is the purpose of control unit. It just takes the instruction from the memory and it just processes the data. Then we have ALU, Arithmetic Logic Unit. Its purpose is to perform basic mathematical operations. It also performs logical operations as well. Okay, now the second is next one is the secondary storage. Storage unit. The storage unit, the purpose of it is to hold data and instructions that are entered through the input unit, and before they are processed, then it preserves the intermediate and final results before they are sent to the output device, and it saves the data for the later use. Okay, one thing here I want to clear that you can see the legends. I know the picture is not very much clear, but you can see in your figure as well. You can see the flow of data with the dotted line, flow of instruction with the semi-dotted line, and the flow of control with the straight line. Okay, the next is the computer storage is divided into two categories. First is primary memory, and second is the secondary storage. It is primary storage or secondary storage, but we call it as a primary memory or secondary memory. Okay, now first we are discussing primary storage. And primary storage, the purpose of it has to store and provide the very fast results. What happens that the program comes from the instructions or the data comes from the input unit first into the primary memory. So the purpose of the primary memory is to provide and store the results very fast, and it holds the program being currently executed in the computer. If you are running a program and you are not storing it somewhere, so the data will be lost. So primary memory is a volatile memory. Volatile means that is a temporary memory. The programs or the data is lost if the computer is turned off. That is why some of our data is lost when we turn off the computer without saving it, because it was in RAM or temporary memory while you were working on computer. Okay, it is temporary in nature. The data is lost when the computer is switched off, and if you want to store the data permanently, so the data has to be transferred to the secondary memory that is outside the motherboard. Okay, but the cost of the primary storage is more as compared to the secondary storage, because we are saving the data permanently, so the cost will be greater than the secondary storage. Okay, so now primary memory is further divided into two types. That is, first is random access memory, and the second will be ROM, read-only memory. Okay, now random access memory is a kind of memory from which we can read and write on it. Means instructions can be taken from input device and can be written to or can be sent to the output devices. It is volatile, means it is temporary in nature. The data is lost when the computer is switched off, and the information is just stored temporarily. Since it is volatile, that's why. Second type is ROM, and the ROM from which we can only read but cannot write on it. Means the data can only be taken from secondary storage to the ROM and can be displayed to the output unit, but we cannot write anything. It means we cannot process anything. But this type of memory is non-volatile, means the data will not be lost if the computer is switched off, and the information is stored permanently in such memories. But a ROM stores such instructions that are required to start a computer. Means if you want to start a computer, those instructions are stored in ROM. Okay, now second type is secondary storage. It stores several programs, documents, databases, and means the permanent storage. And if the results, we want to save the result, so they are saved in secondary memory. It is slower and cheaper than the primary memory because the primary memory is not storing anything. That is why it is faster. But secondary memory has to store something, so it is slower and it is cheaper because it has not much work to do other than saving. And commonly used storage devices are hard disk, CD, etc. Okay, the next is the input unit. As we all know that we have input unit which can be one or more input devices, and commonly used input devices are mouse, keyboard, floppy disk drive, magnetic tape. All input devices perform the following functions. Um, what is the purpose of input unit? That it accepts the data and instructions from the outside world, then convert it into a form that the computer can understand, then it supply the converted data to the computer system for further processing. As you can see from the figure that input unit means if you are using mouse or you are using keyboard, so you are giving the input, then it will convert it into a form that the computer can understand, then it will supply the converted data to the computer system for further processing, and the further processing will be done in the primary memory part. Then the output unit simply it provides the information and results of a computation to outside world. Okay, so after the processing inside the primary memory, the result will be forwarded to output unit. And the commonly used output devices are printers, videos. Okay, the output which you will see on monitor. Now the commonly used output devices are printers, visual display units, floppy disk drive, hard disk drive, and magnetic tape drivers. These are just examples. Means you can save into your output devices. Okay, now the functions of the CPU. First is it interprets the data and instructions. Data and instructions given by the user are easily understood by the computer, of course. Because the devices means the input unit converts the data into a computer understandable form. Okay, it generates control signals. Okay, what do you mean by control signals? It is a pulse of electricity which tells the computer any control command over a network. Means, how is it going to know that it has to perform something? If I'm sending the data on uh, into a computer through my input device, so first it will uh, pass the signal, and that signal is just a pulse of electricity which will be received by the computer, so it will start the further processing. Okay, now it performs arithmetic operations, means addition, subtraction, multiplication, and division, and also logical operations. We have discussed in logical operations that it is an operation that analyzes one or more inputs and generates a particular output based on a set of rules. For example, comparison. If I want to compare two numbers, that is 1 or 2, so which one is greater? So then logically the answer will be greater, means which number is greater? Obviously 2. So it will logically compare them. So the answer will be 2. Okay, so as you can see, don't worry about the figure. PC, MAR, MTR, IR, and ACC are the registers. We will discuss what are registers in the upcoming slide, and the data will be generated from the registers, then it will go into the random access memory, that is your primary memory. And if it has to perform some arithmetic calculations, so it will forward it to the ALU. Okay, it produces the address which needed by the memory. Memory address is the reference to specific memory, and address is the location of data, usually in main memory or in a disk. Basically, just consider address bits. If you are living somewhere, so you must be having a house number, street number, area, something. So in the same way, computer addresses are defined, and they are defined in bits. So consider computer memory as an array of storage boxes. This is just the example of array. Array means the just like the structure of boxes, and each box has an address or a unique number assigned to it. Okay. Okay, now the next is the arithmetic logical unit, and what are registers. Now we will discuss what are registers. Basically, a register may hold an instruction, a storage address, or any kind of data such as a bit sequence or individual characters. Instructions specify registers as part of the instructions. Basically, these are the temporary placeholders, or the means you can say if you are working on some instruction. Okay, we want to add two instructions. So the two numbers which we are going to add, those will be stored somewhere. That some place is the register. Temporarily they will store that two numbers in register. Then after the result they will provide on the output side. So they are high speed volatile, means the data is lost after the computer's turned off, or temporary memory locations built directly into the CPU. Okay, it holds the data currently being processed, of course. And for example, I am giving the same example that the control unit might load two numbers from the memory into the registers in the ALU. Now, what is the purpose of arithmetic logical unit? It can add, subtract, multiply and divide, and it can also perform logical operations. So now they are loading two numbers from the memory into the registers in the ALU to perform some function. Okay, don't worry about the figure. This is just the ALU. A and B are the two numbers, and these are the instructions. Suppose add is on 0, subtraction is on 1, multiplication is on 2, division is on 3, or and not and XOR. These are the logical operations. Don't worry about these logical operations. We don't have to go into the detail, but we will consider them as the logical operation. Means the result will be on some logic. The C2, C1, C0, C0 is the control line, and first of all the instruction is decoded. Simply decoded means कि control unit से हमारे पास instruction आती है तो पहले वो decode करता है, यानी कि जैसे code word होता है ना, तो देखते हैं कि instruction किस लिए आई है. मतलब it has to perform arithmetic operation or it will perform some logical operation. So accordingly it will perform the instruction. Means if the two numbers are going to be added, so A and B will go from the top, and the particular function will be performed from this side where is the control line. Okay, so then it might tell the ALU to divide the two numbers. Yeah, here they are taking the division operation. So the two numbers are loaded at the top. Then if we are going to divide, so it will go to the number 3. Okay, now what if they want to compare? So suppose they are going to take the last one. I'm not talking about the 4, 5, 6 and 7. I'm just taking the for example. Okay, next, all calculations are performed in the arithmetic logic unit of the computer, and it also does comparison and takes decision. Okay, so what do we conclude? That ALU can perform basic operations such as addition, subtraction, multiplication, division, and does logic operations. And logic operations can be of greater than, less than, or equals to. Okay, so what do we concluded? ALU performs arithmetic and logical operations. Then control unit transfers the data from storage unit to ALU once the computations are done. So the control unit which is present here, these are the control lines, but we will discuss control unit in the next slide. Control unit basically transfers the data from storage unit to ALU once the computations are done. Then results are transferred to the storage unit by control unit, and then it is sent to the output unit for displaying results. Basically it is the control unit. Controlling unit means कि it is just like a traffic cop. कि traffic signal पे जो हमारे पास पुलिस होती है, ट्रैफिक पुलिस, उनका क्या काम होता है कि कंजेशन ना हो, मीन्स कि ट्रैफिक ब्लॉक नहीं हो और वो एक वक्त में एक लेन को जाने दें. सो इन द सेम वे कंट्रोल यूनिट ट्रांसफर्स द डेटा फ्रॉम स्टोरेज यूनिट टू द ALU. देन आफ्टर द कंप्यूटेशंस, जब रिजल्ट्स हमें ऑब्टेन हो जाते हैं तो उसके बाद वो वापस स्टोरेज यूनिट में भेज देता है. कौन? कंट्रोल यूनिट. और फिर वो रिजल्ट्स आउटपुट यूनिट पे डिस्प्ले होने चले जाते हैं. Next is the control unit. Simply, what is the control unit? It allows some data to travel in one direction and stop at the stream sequence of data elements of data so that no path is congested. The same way, if it is like a traffic police, so it will allow only one direction. अगर दोनों direction से data आ रहा होगा तो क्या होगा? Collision हो जाएगी. So no data will be processed. It takes instructions from memory and processes the data the same. It just takes the instructions from RAM and processes the data. Do remember the diagram of कंप्यूटर सिस्टम विद सब यूनिट्स, जिसमें हमारे पास प्राइमरी मेमोरी है और वहाँ से हमारे पास डेटा आता है प्राइमरी मेमोरी में। कहाँ से आता है? इनपुट यूनिट से। फिर प्राइमरी मेमोरी में जितना भी डेटा आया है वो उसको प्रोसेसिंग के लिए कहाँ से करेगा? कंट्रोल यूनिट या फिर अरिथमेटिक लॉजिक में। बेसिकली कौन कर रहे हैं? कंट्रोल यूनिट से मेरे पास कहाँ गया? ऊपर। अच्छा, अगर आप डायग्राम देखें तो प्राइमरी मेमोरी से एक एरो पार्शियल सेमी डॉटेड लाइन जो है वो कंट्रोल यूनिट पे जा रही है. सो आफ्टर दैट कंट्रोल यूनिट विल डिसाइड आइदर द इंस्ट्रक्शन हैज टू परफॉर्म सम अरिथमेटिक और लॉजिकल ऑपरेशन or not. So after that processing it will send back to primary memory the results, and after primary memory either it will be stored to the secondary storage or it will be directly displayed by control unit to the output unit. Okay, then the control unit of the CPU comprises of registers which function as temporary storage devices. Again, it also has some registers. What are registers? Registers are temporary storage holders. Then it extracts instructions from RAM and decodes and executes them. Again, what do you mean by decoding? Means कि इंस्ट्रक्शन आएगी पहले वो उसको आइडेंटिफाई करेगा कि it is either arithmetic logic unit, either it is arithmetic operation or a logical operation. Then it will execute, mean it will process the data, then it will call the ALU, and then control unit regulates operation on a computer by directing data flow within the CPU. Okay, it also controls input and output processes to and from memory. So basically control unit is just like the principle of computer system, means that it controls what kind of data is processed from input and output devices, and either the data is from or to the memory, and how the instruction is to be executed. So a control unit interprets and carries out instructions of computer programs, and it selects the program statements from memory and moves the instructions to registers in the control unit and carries out instructions. Okay, now you have to do these 3 questions. The answers are already on the portal, you can see from there. And if there are any questions you can ask in the class. Jazakumullah khair.